Alrighty. A woman wants to cross a river 60 meters wide and the river flows at 13. Alright. Is she capable of going straight across? Can she get straight across on her boat? Why not? Yeah, the velocity of the river is too fast and it just simply ain't going to happen. So that's 13 and this just isn't going to happen, okay? So in theory she could aim all 5 to the left. She won't move up or down, she'll just get swept to the right at 8. Does that make sense? So basically what's she looking for? Does she want to get over as fast as possible or the smallest distance possible? Alright. So it gives us an angle that she's going to use, doesn't it? So let's lay out our law here first, okay? We call this boat in river, okay? So boat in river. Velocity of the boat in the river is Vb minus Vr. The velocity of the boat therefore is the velocity of the boat in the river plus the velocity of the river, or the velocity of the boat in still water plus the velocity of the river. Is that right? Now we're going to aim upwards at an angle that we don't know. So I'll aim upwards at this direction here. We'll call this direction alpha. You okay with that? Now what are the two components then? It's going to be 5 sine alpha and 5 cos alpha. Is that alright with you guys? Okay. Now what else does it say? Show that her actual velocity, her actual angle downstream is theta. So what did we say earlier? She's not going in that direction. She's actually going to get swept downstream like so. Is that okay? Now, I don't know if it's going to be like that or like this. I don't know the angle. Is everybody cool with that? I don't know what the angle is, so I'll just put it here. Okay? Now, and we call this theta. Is that okay? Now, theta is the actual velocity of the boat. So what we're going to do is we're going to determine the velocity of the boat, both its I and its J components, using our little rule over here. So everybody ready for this? Velocity of river, 13I. Velocity of boat in river, or boat in still water, is going to be 5 cos alpha I. Sorry, minus 5 cos alpha I plus 5 sine alpha j. Okay, next step after that is the velocity of the boat, which is add the two of them together. So it's going to be 13 minus 5 cos alpha I plus 5 sine alpha j. Now, what does that mean for our diagram up here? Well, if I finish this triangle off up here, what essentially means is that the opposite is the yellow one and the adjacent is the blue one. Ever cool with that? So tan theta will be one of them divided by the other one. I'll pause here for questions. Lads, just to tell you, phi b is where the boat actually goes, and what we said is that the boat is here and it tries to go this direction, but it actually gets swept downstream, and the direction it actually goes in is up this direction here, right? So that's where phi b actually goes, and that's why we use the angle theta here. and it goes using this velocity down here, the phi b velocity here, which this one here. That's the one that actually drifts downstream at that speed. Okay, we all good? Done. So we're at this stage here where we have our angle is good. Now, I'll just draw everybody's attention for a second. Okay? Different values of alpha will result in different angles of theta. Do you get that? So, different values of alpha could be basically, alpha could be really, really small. Why can't it be 90 degrees? Why can't it be 90 degrees? Not powerful enough, that'd be going straight across, wouldn't it? So we're talking like we want it to be as close to vertical as possible. When you're as close to vertical as possible, that means you're swept downstream to a minimum. If it's really, really, really small, you're getting swept downstream a lot. So what we want to do is we want to figure out when will it be a maximum. Is that okay? Now, good job. Using calculus or otherwise, prove that it has a maximum when cos alpha equals 5 over 13. Okay. Yes?
How do you show that tan alpha is 5
Sorry, you must have missed that part, Michael. See this here? That's theta. The yellow part is the j component of your velocity. The blue part is the I component of your velocity. Tan is opposite divided by adjacent, which would be 5 sine alpha over 13 minus 5 cos alpha. Is that okay with you guys? Now, I used to have two ways of doing this one. Oh, this is going to be fun. Trying to remember this. Alrighty. Now, suppose we can try the calculus way as well. Calculus way is to differentiate top and bottom. Alright, let's think about tan. Think about tan as a function. What happens to tan? Tan 0, lads? 0. Tan 20? 0.36. Tan 40? 0.8. Tan 70? 2.7. Tan 89? 57. Tan 90? Undefined. So, isn't it safe to say that we want this tan value to be as large as possible? Is that alright? So what we're going to do is we don't need to differentiate the tan part. We just need to differentiate this part here. We know that we want it to be as large as possible, so we're just going to concentrate solely on differentiating the yellow part. Is that okay? So let's do this. Y equals 5 sine alpha over 13 minus 5 cos alpha. Okay, we're going to use the quotient rule, aren't we? So u equals 5 sin alpha. So what's the u d alpha? Anybody? So what happens when you differentiate sine? Yeah, cos e days, and then underneath, when you differentiate, v is going to be 13 minus 5 cos alpha. Is that okay? So what's the v d alpha? Anybody remember? Differentiate 13, what happens? 0. Differentiate cos, it turns into? So what's minus 5 minus sine? 5 sine alpha. Okay. If you remember correctly, it's usually v du dx minus u dv dx, okay? All over v squared. So let's do that here. And for argument's sake, we're just going to call it dy d alpha. Okay. Yeah. So what do we do here? Phi is what? 13 minus 5 cos alpha. Du dx is 5 cos alpha minus u times the v dx, so it's going to be what is it, sine times minus 5 sin alpha. Now what's the next part? 5 sin alpha the v dx, which is 5. Can you close that door? Thanks. Sorry, u times the v dx. So u and the v dx are oddly enough the same thing. That's what's confusing me. All over phi squared. Did any of you get this far? Fair play. Okay. Now, let's multiply all this out. What we should get is 13 multiplied by 5 cos is 65 cos alpha minus 25 cos squared alpha minus 25 sine squared alpha. Why am I super relieved to see that? Anybody care to tell me? Sorry? Yeah, cos squared alpha plus sine squared alpha is 1. So essentially it's minus 25 brackets cos squared alpha plus sine squared alpha. Now, the first derivative of turning points equals what? 0. It's a maximum, it's a turning point, and the first derivative has to equal 0. That will leave me with 65 cos alpha minus 25 on top. Does the denominator matter? If the answer is 0, does the denominator matter? No, it's only the numerator that matters. And then you're going to get 65 cos alpha equals 25, and then cos alpha is 25 over 65, which is 5 over, is it 5 over 13 is the answer? That's all we wanted. Believe it or not, I have a much quicker way of doing this, but that can wait till the next day. I have a really super quick way of getting these done. That's the first time I ever showed anybody the calculus way. Never used it before, so this is fun. Alright, yes sir.
What are the last 3 steps?
Last 3 steps. Okay. Were you there when we found out that tan theta has to be a maximum? We used the quotient rule to differentiate. We used the quotient rule to differentiate 5 sine alpha. What? Oh, so a bit further down, is it?
Yeah. No, I got the answer.
Huh?
I got it.
Sure. Alright. So what question was that, Killian?